I will be speaking to you about three main aspects. The first being, why do we combine chemistry and computers? Secondly, where does high performance computing fit in? And finally, how do you ensure that the chemistry applications which are running on your HPC environment actually perform optimally? Why combine computers and chemistry? Traditionally, creating a new drug in the pharmaceutical industry is a difficult and expensive process. It used to cost more than $1 billion and took approximately 10 years to develop a single drug. Over the years, researchers have developed a tool called computer-aided drug design, which is something that is widely used today to assist with the drug development process. This has resulted in a drop in the drug development costs and significantly reduced the development time. We're currently experiencing a pandemic known as COVID-19, or its biological name, SARS-CoV-2. Now, if I show you guys this image, you will all know this as the COVID-19 virus. However, this is not what this virus actually looks like. This is just a graphical representation of what it looks like, and it's been done by some graphical expert. The virus itself looks like this, and were it not for the combination of both chemistry and computers, one would never know what this biological system actually looks like. What are the types of codes that one would expect to run on a high-performance computer? Here I provide a list of computational chemistry and material science codes that I have installed on the Center for High Performance Computing supercomputer. There are a number of them ranging from both licensed codes and open source codes. I will be focusing on those that are highlighted in red for the rest of this presentation, and I will be showing you what the different types of benchmark results I have obtained for these different applications. First application we will be looking at is Quantum Espresso. This is an application that is used mainly in materials modeling. You will notice that I have two different sets of compilers, one being GCC 6.1.0 and the other PGI 19.10. The GCC 6.1, along with all the other compilers listed in that row, are used specifically for CPU runs, whereas the PGI compilers are used for GPU runs. If we have a look at the results that we currently have here, you'll see that right at the bottom I have all of the CPU runs ranging from 24 CPU processes up to 120 CPU processes, and those are the relative speedups that I've obtained for the different CPU runs. Above that, we then notice that I have a number of GPU runs. So these are your graphical processing units, and you notice there's substantial speedup compared to your standard CPU runs. This shows that this application actually performs much better on a graphical processing unit compared to a central processing unit. Next application we're going to look at is GROMACS. This is one that's used in biological modeling. So here you'll notice that I made use of two different types of GROMACS versions, one being 2019-4 and the other 2020.1. Below that, you see that I have the sets of compilers that I made use of in order to get these applications to run. Here are the results that are obtained. And again, as in the case of Quantum Espresso, we see that the ones that ran on the GPUs actually perform significantly better than those on the CPU. And we also notice that the 2021 version outperforms the 2019-4 version. In this application's case, you also need to make use of what's called thread MPI ranks. These actually exploit the GPUs better than using standard MPI to run the application. The last application we are going to look at is AMBER. This is also a biological modeling application. Here again, I've listed the compilers which I've used in order to get this application up and running. From the results, we once again see that running this application on graphical processing units is substantially faster than running it on the central processing units. In essence, you can see that GPUs are essential for applications such as this. From the results obtained, we can conclude that graphical processing units are essential for computational chemistry and material science applications. The speedups will allow researchers to obtain more data in shorter periods of time. This means that development of new drugs for viruses such as COVID-19 can happen much faster. Without HPC, none of this would be possible. Thank you for listening.